Okay, so just like we can do quick chains, we can kind of do quick anti-chains, which would actually be u-substitution in reverse, but doing it quickly. So let's review and practice along. So hopefully you wrote down all of the memory lists, so you can send that in to me just to make sure you've written it down one more time. Let's go ahead and do some quick u-substitution problems. So these are the easy ones that you shouldn't really have to think about when you do. In fact, you're going to kind of do more of a guess and check. So these are quick u-substitution / guess and check. So if I had the integral of the sine of 2x dx, wouldn't need the parentheses around the 2x, but let's just say we do put it there. The long way of doing this is a full out u substitution. We let u equal 2x. Therefore, du dx is equal to 2. Therefore, du is 2 dx. Therefore, dx is du over 2. And we could rewrite this as the 1/2 will come out, and this becomes the integral of the sine of u du. And we know how to do that. That would be 1/2 with a negative thrown in, negative 1/2 cosine of u plus c, and we know that that's negative 1/2 the cosine of 2x plus c. We could have done that faster, sort of with a guess and check. If the way I check if an answer is right is I take the derivative, all right? So when I look at this, I know that the antiderivative will have a cosine of 2x. So when I turn around and take the derivative of that part, I'll have a negative, okay? Oh, we had the negative there, so let's bring that negative in. So we know that we'll have a sine of 2x, and then by our quick chain rule, we would multiply that by a 2. So we know that when we take the antiderivative of sine of 2x, we'll have to have a negative cosine of 2x. And therefore, when we go to check the answer, we're going to be multiplying by 2 one more time. So the 1/2 would have to be there to undo the multiplication by 2. So we probably could have guessed right off the bat that our answer would have a factor of 1/2 right out here, because when taking the derivative, we multiply by 2. Therefore, when taking the antiderivative, we must divide by 2 or multiply by half an extra time. So the quick way to do that would just simply be, say, the sine of 2x dx. Let's do a quick guess. We know that we'll have a negative cosine of 2x, and we'll have an extra factor of 1/2 to compensate for the 2x in here. And you make that quick guess, and then you could quickly in your head check that, and that will in fact be the right answer. So let's do the same thing with a few more of these. Okay, we'll see a pattern emerge here. So sort of series 1 here. If I had the integral of cosine of 2x, see if you can guess your way to an answer for that. Okay, so my thinking is we have a 2x here. All right, so we're going to need to have an extra factor of 1/2 showing up in order to compensate for that when we take the derivative. So the antiderivative, maybe better yet, let me erase that. The antiderivative of cosine has to be a sine. And if I'm going to get a cosine of 2x, it better be a sine of 2x, so that when I take its derivative, I'll have a cosine of 2x. But because of the extra factor of 2 inside, I'm going to put an extra factor of 1/2, so that when I do the quick chain, we'll compensate for the multiplying by 2 by putting the 1/2 there. Obviously, you put a plus c on. And so there we have the answer. We can quickly do the same thing for things like e to the 2x dx. Once again, there's an extra factor of 2. E to the x gives me e to the x back again, so I better get an e to the 2x. If I throw a 1/2 in front, when I take the derivative of the answer, it will in fact get me back to the integrand, which is the proof that it is correct. So the factor of a half will compensate for the 2x. All right. Same thing if I were to do, this is a good one to be able to do. We know the answer has to have an e to the negative x. Therefore, to make it work, when I take the derivative, I better put an extra factor of -1 out there. Okay, the answer would have to have an e to the negative x squared. But this was a trick. There is no method of integration that will simplify that. So that actually becomes its own integral function, the ERF function, ERF function. This is ERF of x. You can't reduce it down any further. Okay. So let's move on to another series. Okay, so in series 1, we simply had a proportionality in here. 2x, 2x, negative x. This was not a proportionality, so it didn't work. In series 2, we're going to go from proportionality to linear, right? So if the inner function is linear, the same thing works. I know that the antiderivative has to be a negative cosine, so I'll put a negative. I'll leave a little space, cosine of the same thing back again. I know that the derivative of 2x plus 5 is 2. So I need to put a factor of 1/2 to compensate for the 2x plus 5, which has a derivative of 2. So once again, here's the thinking on this. I know that the antiderivative of sine must be a negative cosine, but it's a negative cosine of 2x plus 5, and I know that the derivative with respect to x of 2x plus 5 is 2. So when I go to do my check of the answer by taking the derivative, I'll get an extra factor of 2, which I compensate for with that 1/2, right? So that will be the antiderivative of the sine of 2x plus 5. Okay. Let's do a couple more. See what you can do with these. Do it in a similar fashion to what I just did. I'll put in the answer in just a moment. Okay, we know the antiderivative must be the sine of 2x plus 5 plus c, but because of the 2x, I need to 2x plus 5, its derivative is 2. I need to throw in an extra factor of 1/2 to make it all work. When I go to check the answer by taking the derivative going back the other way. So when I take the derivative, go back the other way, I get an extra factor of 2, so I better also get a factor of 1/2, and that makes the whole thing work out, right? A couple more. Just make it a little bit more complicated. Pretty common thing to see. We have a sine function, which is, in this case, slightly compressed. Pi over 3 is just a little more than 1, and it's moved 2 spaces over to the right. So what would its antiderivative look like? Go ahead and see if you can figure it out. And by the way, this is everything that I have in the argument is a linear function. So this fits the mold of being linear. Ask yourself, what is the slope of that linear function? Okay, so the antiderivative must be a negative. Leave a little space for the correction factor. Cosine of the same argument back again. I know that the derivative of the argument is just pi over 3. So now that's a fraction. So the opposite of multiplying by pi over 3 is to, let me do this in red, put a factor of 3 over pi in. So that's what, just like 1/2 is what will undo multiplying by 2. 3 over pi is the factor that will compensate for a factor of pi over 3. So that will make this one work out. Okay, let's do another one of those. Let's do E. Whenever there's an E, you know it's going to be easier. We love E. Go ahead and see if you can figure that one out. Okay, the antiderivative has to have e to the 2x plus 5 back again, plus c, and then we need a correction factor. The derivative of all of that will be 2, so my correction factor is 1/2. Let's do one more, just slightly trickier. The integral of the square root of 2x plus 5 dx. Let's see what you can do with that. Okay, so we're working with a half power. So the antiderivative goes up 1. So I must have 2x plus 5 to the 3/2 power. So by the way, I'm thinking of this as 2x plus 5 to the half. Okay, so it must go up to 3/2, which means I already need a factor of 2/3 plus c. But then I need my correction factor. So the derivative of this is 2. So I get a correction factor of 1/2 to compensate. And so the total answer, the final answer, will just be 1/3 2x plus 5 to the 3/2 power plus c. If you're not 100% sure, then go ahead and take the derivative of all of this. You would multiply by 3/2. All right, so you would end up with a half, but then when you do the chain rule on the derivative, you'll get an extra factor of 2, and it will in fact work out. Okay, so the point of this is I can, just like I can very quickly take derivatives of things like e to the 2x by throwing in an extra factor of 2. I can also take antiderivatives, since it's the opposite process. Instead of the chain rule giving me an extra factor of 2, I need to remove a factor of 2 to get back to the right answer. Okay, so in those kind of problems, you don't want to have to write it all out. You want to be able to quickly guess your way to what the answer should be, what the antiderivative should be, and maybe do a quick mental check and save a lot of time.